Hello my dear students, welcome back to another session of real numbers. In our previous session, we have discussed about Euclid's division lemma. Let's see its application in today's session. I have to pack donuts and pies along with Christmas gifts to all the friends who visits my house. I have 210 donuts and 252 pies. What is the number of each item that can be placed in each pack for this purpose? This you can try doing by trial and error method. But don't you think it is a tedious job? So for that, can we find H.C.F for these two numbers that you have learned in our earlier grades? Okay, then H.C.F will give the maximum number of items in each pack. I am using the long division method to find the H.C.F. Here, the bigger number among these two numbers is 252. So 252 is the dividend and other number is 210 which is divisor. So 210 divides 252 one time, leaving 42 as remainder. Now in the second step, 42 the remainder becomes the divisor and 210 is the dividend. So 42 divides 210 5 times exactly. So the remainder is 0. Here, H.C.F of 252 and 210 is 42. Therefore, I can make 42 packs of each kind. Here, I am expressing this long division method in the form of a numerical expression. See here. So, 252 can be expressed as 210 times 1 plus 42. Again, 210 is equals to 42 times 5 plus 0. That means dividend is equals to divisor into quotient plus remainder, which is Euclid's division lemma. Here, Euclid's division lemma is applied to find the H.C.F of these two numbers. The application of this lemma is nothing but Euclid's division algorithm. This algorithm helps to compute the highest common factor, which is nothing but H.C.F of any two positive integers. What is an algorithm? An algorithm is a series of well-defined steps which provide a procedure of calculation repeated successively on the result of earlier steps till the desired result. So, let us state Euclid's division algorithm clearly. Obtain the H.C.F of two positive integers, say C and D, with C greater than D. Apply Euclid's division lemma to C and D. So, we find whole numbers Q and R such that C equals to D into Q plus R. Here, 0 less than R equals to R less than D. If R equals to 0, then D is the H.C.F of C and D. If R is not equals to 0, apply the division lemma to D and R. Continue the process till the remainder is 0. The divisor at this stage will be the required H.C.F. This algorithm works because H.C.F of C and D equals to H.C.F of D and R. Let us take an example and find H.C.F using Euclid's division algorithm method. So I am considering two numbers 135 and 225. Here the biggest number among these two numbers is 225. So 225 is the dividend and 135 is the divisor. Now apply division lemma, that is dividend is equals to divisor into quotient plus remainder. So 225 can be expressed as 135 times 1 plus 90. Since the remainder 90 is not equals to 0, so apply the division lemma to the divisor and remainder of the first step. So 135 is dividend here and 90 is the divisor. So 135 can be expressed as 90 times 1 plus 45. Again, the remainder is 45 which is not equals to 0. So apply division lemma to the divisor and the remainder of the second step. That is 90 is the dividend and 45 is the divisor. Now again 90 can be expressed as 45 times 2 plus 0. Here the remainder is 0. Therefore 45 is the H.C.F of the numbers 135 and 225. If you observe properly, the H.C.F of 90 and 45, H.C.F of 135 and 90 and H.C.F of 225 and 135 are equal. Euclid's division algorithm is not only useful for calculating the H.C.F of very large numbers, but also because it is one of the earliest examples of an algorithm that a computer had been programmed to carry out. Euclid's division lemma and algorithm are so closely interlinked that people often call the former as the division algorithm also. Although Euclid's division algorithm is stated for only positive integers, it can be extended for all the integers except 0, that is b is not equals to 0. However, we shall not discuss this aspect in your 10th grade. We shall solve more problems on this concept in our upcoming sessions. Hope you find this video helpful. See you guys. This is Sabita signing off.